So in this video, we're going to cover the applications of the dot product in this course. So in this course, we'll typically use the dot product in two cases. The first case, if we want to determine the angle between any two vectors. So we know that cosine of theta from our dot product definition is going to be equal to the dot product of vector B, vector A and vector B divided by the product of their magnitudes. So the magnitude of vector A times the magnitude of vector B. All right, so we can rearrange that and solve directly for theta, obtain the inverse cosine of that. So we know that A dot B we just solved for in the last is just equal to the sum of AX times BX plus AY times BY plus AZ times BZ divided by the magnitudes of vector A and vector B. All right, so the second application that we will use is we can find the components of a vector that would be parallel or perpendicular to a line. So in order to do this, we can have, so we're going to just show this in 2D. It'll be a little simpler to show. So we have our xy coordinate system, and let's say on our xy coordinate system we have one vector. We'll call this vector A. Right? And we have another vector, vector B. All right. And we want to determine what is the projection of vector A onto vector B. All right. So we want to know is what is the part or the component of vector A that is perpendicular or parallel with vector B, and what part of the vector of vector A is perpendicular with vector B. So, all right, and we know the angle between those two vectors. All right. So we're first going to calculate the whatchamacallit. We're first going to calculate the parallel component. That's a little simpler to do. So we know the magnitude of our parallel component of B is going to be equal to the magnitude of vector A times the cosine of the angle between the two, or cosine of theta. All right. You can also calculate it if you don't know the angle between them, but you do know vector B. You can calculate the unit vector of vector B. All right. So you can say that the magnitude of vector A times well, if you take the dot product of vector A, sorry, not the magnitude. If you take the dot product of vector A with the position or the unit vector of vector B, you can also determine the magnitude along the parallel direction. Okay, so this is just the same thing. Again, the unit vector is just equal to vector B divided by its own magnitude. All right. So then, once you have the parallel component of vector A with vector B, you can calculate the perpendicular component's magnitude, or the component of vector A that's perpendicular with vector B, by taking the magnitude of vector A and multiplying by the sine of theta. You can also, if you don't know what the angle theta is, you can solve for it using just the square root of the magnitude of vector A squared minus the magnitude of the parallel component of vector A with vector B squared. Okay. All right. So just to conclude, the two, just to recap, the two applications of dot product. The first application is we're going to find the angle between any two vectors, A and B. The second application is we will find the projection of a vector that's going to be parallel or perpendicular to a given another vector. Okay, so in this case we solved for the projection of vector A onto vector B, but we could just have easily figured out the projection of vector B onto vector A as well. All right. So, all right, so that concludes this video.